Hello, Ruth.
Hello.
Hello, Anirudh.
Hi, Yogesh.
Okay. So, do we also have Ruth online? Can you hear us?
Yes, I can.
Okay. Did either one of you get a chance to try out a couple of designs, test benches, simulations?
No, I didn't get time.
Okay.
Me either.
Okay. So this class, actually, even last class and this class is about practice and any also for any questions that you might have. Okay, for anything related to the training that we have seen so far. So, any topic that we have covered, any questions or something that you have not understood, you're free to raise them right now.
No questions as such from me, from my end.
Okay.
Uh,
I'll just sorry, Ruth, go ahead here.
no, I said none for me either.
Okay, so I'll just summarize what we have done through the course of the training. Initially, we did a quick refresher on digital logic design, combinational circuit, sequential circuit, FSMs. Then that followed by a little bit overview about FPGA design, FPGA, how they compare with respect to embedded microcontrollers or semi-custom ASIC design, full custom ASIC design, which are the FPGA vendors, what is the typical applications of FPGA, and we saw a little bit about FPGA architecture, internal architecture of the FPGA. Then we saw why do we need HDLs, hardware description languages, and how the design methodology compares between HDL based methodology and the older schematic based methodology. So we saw some differences there, followed by why do we need HDLs, and once we justify having HDLs or usage of HDLs, what do we need from the hardware languages or hardware description languages. We saw a little bit about Verilog, history about Verilog language. It was a proprietary language earlier, then slowly it became IEEE standard, and where it got open to the general public for usage. So then we looked at various aspects of Verilog design. So normally there are two methods while using Verilog language to design digital circuits. That is structural modeling and behavioral modeling. So structural modeling contains basically creating a structure yourself, instantiating gates, instantiating other modules or other components from the library directly if it's required, and creating port mapping the signals, input output signals, and creating the structure yourself. Behavioral modeling is something where you describe the behavior of the circuit, the digital circuit using Verilog, and let the synthesis tool then convert it from Verilog language to gate level netlist. So there are two methods, and using these methods, how do you design combinational circuits? First part we saw that, and then how do you design sequential circuits using structural or behavioral modeling? We saw some examples related to that. Then we saw a couple of examples related to FSM design. FSMs again are two kinds: finite state machines, Moore FSM, Mealy FSM. Moore FSM is a kind of FSM where output is dependent only on current state, whereas Mealy FSM is a kind of FSM where output is dependent on current state and the input value. So we saw a little bit conceptually between these two kinds of types of FSMs, and how do you model these two FSMs using Verilog. So we saw a couple of examples there. Then we also saw memory design, which is also falls under sequential, but something that we saw. How do you design a memory? how do you model a memory? Uh, After that, it was subroutines, functions, and tasks. So, what is part of functions? What is part of tasks? What is something called system task that is used for simulation purpose? So, anything that starts with a dollar sign is a system task which is used for simulation to display certain values or to deal with file input output, file IO operations. So, those kind of system tasks are used for simulation purpose. Then we saw how to write a test bench. So this was about designing a circuit, and we would like to test the circuit. So how do you write something called a test bench in Verilog language again? What is time scale? What is a test bench? How does it look like? How do you instantiate the design that you're going to test? How do you pass inputs to the design? How does a design generate the output, and the outputs are again traced or we track the outputs at the test bench level. So at the test bench level, we look at the inputs, look at the outputs, and then we simulate the test bench and the design, and we generate a timing diagram. Based on the timing diagram, the inputs to the design and the outputs coming back from the design, we analyze whether this is a functionally correct behavior or not. If it is not, then you have to fix it either in the design or the test bench, wherever the error is. So we fix that and we do this iterative process till we get the correct timing diagram, the correct functional result. Once we achieve that, we say our design is working correctly and is functionally verified. That's the end goal for as long as the simulation step goes. And I gave you a demo of a couple of designs at the simulation to how to run the entire simulations, how to use ISC, Xilinx ISC, how to create a project using Xilinx ISC, how to add Verilog design and the test bench files to the project and simulate the design, generate the timing diagram, and analyze the timing diagram. So this is what we do for any design, whether it's a very small design or very big design at Verilog or language level. We can obviously use other languages to add to the test benches and other things, but at a Verilog language level, this is what we do. And at this point, we hand over the design to the what we call a backend team. The backend team will then take care of synthesis, placement, and routing, any other backend steps that are required. To finally, if it's a FPGA, you program the FPGA and test it on board. If it's ASIC, you generate something called uh, GDS2 format, which is then sent for manufacturing. So the backend team is a separate team, and the backend concepts synthesis onwards are different concepts and different tools are used where Verilog is not used. The software is very per vendor, so you have to learn their software. The vendors that operate in the backend phase are Synopsys, Cadence, and Mentor Graphics, which is not a Siemens company. So Siemens. So those are the companies who design backend software for synthesis, placement, and routing, parasitic extraction, etc., etc. So there's a lot of stuff that goes on in the back end, which is not part of this particular training, but that is something that happens in the back end. So your job as a front end designer or RTL designer stops at writing Verilog, writing test benches, doing the simulation, proving your design is correct as per the design specifications, and then handing over the design to the backend team. Okay. So that's a general flow that you would follow, whether it's a small design or a big design. Uh, Tomorrow, if you join a company where you are joining as a front end designer, this is what you'll be asked to do as a front end designer. And later on, you can progress towards back end, and you can, depending on your choice and your um, obviously, I would like the back end the physical design aspects of it also. All the front end design itself is very vast again, so you can stay in that area for a while. Okay, so that's roughly the summary of the training that we have done. Um, do you feel like you have missed something? Do you have any questions related to anything?
Yeah,
Yeah, Anirudh, go ahead.
yeah, that's all. Like,
Okay, so no questions?
yeah, no questions.
No.
my end.
Okay, so my advice to you guys would be you whenever you get time you practice because that's what is going to help you gain confidence in this practice. I think I have if you Google there are two books. I think I had mentioned this, but I'll mention this again. There are two books. One for digital design. You can Google Digital Logic Design by Maurice Mano. The authors are Morris, Morris. Morris. Second name is Mano, Mano. Mano. Digital Logic designed by Morris Mano. That's one book. You can Google it and find an ebook for that, which is a very good book for digital logic design fundamentals. And then also you can Google another book for Verilog, which is Verilog by Nawabi. The author is Nawabi, Navabi, Nav B for boy, I for India. Nawabi. That too you should find it if you Google it. So that is a good book for Verilog. And there are a couple other books also. You can always Google and find more books on Verilog. So you can use these two books as reference. Or later on, if you are part of any university right now, you might have a good library where you have access to multiple books. You can even refer to those books. But digital logic design fundamentals is something that you can refresh, and Verilog language you can try out and practice more designs along with test benches, all the way up to project simulation or design simulation in Xilinx software. If you practice more, that will help you down the road. Okay. Anything else I can help you with?
Mm, no, that'll be all.
Okay. So this is the end of our training. If you have any other questions later on, you contact the support team from CloudBig Technology, and they will get in touch with me in case you have any other questions. This would be the end of the training. I wish you good luck for your practice and further later on your work in this field. Okay.
Yeah.
Thank you. Thank you.
Yeah.
Bye
Thank
bye.
you.
Yeah. Bye bye.